Okay, so there are specialized tools that can be used to manage data. And what are those tools? What would they look like, etc. So this will take us immediately to some key work that was done in the 60s and 70s about designing this idea of what are called relational databases. But before I dive in, and then of course I want to talk about also this idea of we want to store data and the data lives on beyond our programs. That's called data persistence, right? It persists beyond the running of our programs. So if you want to persist data, databases are one type of persistence which we will discuss. And of course, the older and more robust form is put everything in files. So we'll talk about how will we use Python to interact both with databases and with files. Okay, so that's what we want to talk about today. So quickly, can we take this poll and you share with me your ideas on relational databases and also, your familiarity. Okay, a lot of you are interested. No one is uninterested. That is good. Okay, quite a few of you have learned about databases. Some of you are very familiar. So, okay, so this means that I can go faster. Can I ask some of you to help me as we go along? If you feel that there are some parts of this conversation that are too elementary, speed me on. And if I'm going too quickly in some places, please interrupt me and slow me down, okay? So that we can find the right speed for us to work on. Okay, so let's, since all of, okay, so if you click next here, we'll go into, as soon as my web page loads. Yeah, so just this, I cannot resist making these comments here. The entire idea, it's amazing that an entire field is kicked off by a single person. In this case, much of what we understand today as relational databases was the work of Cord, at that time working in IBM research. It's really cool to look at some of his history. But what is more important is that there is an actual paper here, a relational model for large shared data banks. Those of you who have not read this paper, it might be worth just glancing at this paper. The reason I say is that in this paper, he does something that all of us can aspire to do, which is to look at a problem even before it has become too big a problem and propose natural ways to manage that problem space. So what was the problem he was looking at? The problem he was looking at is that he started, this is in the 60s and 70s, he started to see that data was growing and people were storing data in files. And if you store data in files, then your programs tend to couple very strongly with the structure of the file. And so Cord's idea was, how can we actually decouple the details of the storage of the data and the program, right? And after much thought, he came back with a very elegant idea, which is we should interact with data based on natural structures that are in the data. So for example, we should use relations that are in the data. And if you use the relations in the data rather than the structure of the file, then our programs can be more flexible, general, maintainable, etc. In a nutshell, that's the key idea that drives this whole endeavor. And you can see that he says, if we follow this path, then we get, to a large degree, we get some amount of representation independence. By that I mean, when you work with SQL, you really don't see whether it's a comma delimited file or a tab delimited file. Some degree of order independence. So whether it's a first record or second record is not central to your discussion. Order can always be created. And then some idea that there are different types of strategies to optimize access to the database. So you can get this as well. And a whole lot more. And I'm just going to fast forward through this, but at least to establish some shared vocabulary for us. So his next step was to say, okay, what is the natural structure in data? And his answer was, the natural structure in data is what mathematically you might call a relation. And this is a bigger topic, but since you guys say you understand SQL, I won't go into it. But a relation mathematically can be thought of as a set of tuples, right? And we have covered tuples in Python. So there's a natural reason why tuples and databases and relations are interconnected. And so here's an example of two tuples that represent people. And now you can see immediately why today we would recognize this set of tuples as a table, right? So table is synonymous with relations in this world, and that is one of the key reasons why it's called a relational database. And then once you have tables, you can put indexes on tables so that you can speed up queries, and then you can design these tables with keys and so on and so forth. Okay, and then the next piece here, which we will use a lot today, is SQL. So of course that becomes a separate domain-specific language that if you're familiar with is wonderful. Otherwise, you can spend some time learning it. We will write a few SQL queries today, so we'll just use it and be practitioners. Just a moniker here that's important, I think, is this notion of all the things we do with data as being, cruddy, right? You create data, you read data, you update data, and you delete data. So it's a kind of nice checklist to go through to make sure whenever you're exploring something here, to make sure that the cruddy instructions are something that you understand how to do well. Okay. Then the collection of database tables that you might put together to solve your problem is called a schema. Okay. And of course, we will not be able to go into much of database design, but I thought we would kick off today's conversation by showing you an example. So here is a table. All of you can explore this in leisure. This table looks very much like a spreadsheet. Also does look very much like the first table that anyone might create if you're interested in the domain. The topic that we want to solve here is if there are students and then there are courses, and each course has multiple activities. There are quizzes and projects and so on. And for each of these activities, they get scores, right? So this could be a table that would represent all of the students in a particular institution who are participating in multiple courses, and each course has multiple activities and they get scores on it. And we'll use this as a template for all of our work today, right? So we'll create this database, we will query it, and we will run some stuff. So what is the idea here? Now, I want to say that, first of all, if you look at this data, you will see that there's a lot of data repetition, right? So the course name is repeated multiple times. The student name is repeated multiple number of times. The activities are repeated multiple times, etc. And so this becomes eventually a problem when we have a large amount of data, because there's a tremendous amount of data repetition. It becomes a particularly bad problem when the data has to be versioned. In other words, you must track all changes. And so if you have multiple things repeated, you change something, you have to keep multiple versions, and results in an explosive growth and inefficiency of your data stores, right? And it's very interesting when you work on this topic to compare what happens. And I've seen massive spreadsheets. Spreadsheets naturally tend to look like this. And as the spreadsheet grows and becomes hundreds of thousands of lines, how do you manage your data within spreadsheets and make updates and so on? Okay, so this takes us right into the world where we can bring the powerful tools of relational databases. But I just want to make one more interesting concept before we start writing some code. The way to evolve this data structure is to ask the question, what are the natural, one way at least, is to ask the question, what are the natural entities that are in my data? And the obvious entities that we will come back with are, there are students, there are courses, there are grades, etc. And there are relationships, right? So students take courses, courses have graded activities, etc. And when we evaluate relationships, we can say that, at least you can look at the cardinality. So if I ask the question, what about the relation between students and courses? You can ask the question, is one student in one course or many courses? So one student is in many courses. And does one course have many students? And the answer is a course has many students. So that's an example of a many-to-many relationship, right? So you can evaluate the cardinality of relationships fairly easily. And this simple idea is enough to take you quite a far way, but you have to absorb your domain and apply this carefully. And then you can start creating pretty nice database structures. Okay, so much for theory. Let's go and start writing some code. So again, like last time, if you can click on this link, it should take you to a Jupyter, to a Cloud Jupyter notebook. And if you click on this link, you should see something that looks like this. On the top right-hand corner, there will be an option for you to sign in. So if you click on sign in, and sign in, you need a Microsoft Hotmail account. If you click on sign in, then you can just access it from here. I did not get a sense, maybe I can ask now, if you have installed Python locally, and if you have Jupyter locally, you can just download these two notebooks and some of these helper files into a folder, or basically all of these files into a folder. You don't need the database files, but just all the other files. And then you can run it locally too. But if you don't have a local install, and for today, maybe you can just log in. And after you log in, you should basically click on this clone button, which will clone this database locally. So you have it with you forever until you delete it, at least. You can clone it. And once the clone operation is complete, then you hit this run option. Okay, and when you hit the run option, you will get, so this could take a minute or two. It spins up an entire virtual machine for you with Python running in it. So it can take a minute or two sometimes. And like all cloud things, once in a way, it can have some hiccups too. But don't worry, I will walk you through everything in a live demo today, right? So this is just something that you can have. And if you hit run, then the next thing you should see is something that pops up like this. It's just a browser tree with all those files displayed now in a browser from which you can launch the files. And if you double click on this file, so we'll start with the intro to databases file. So if you double click on this file, you should be ready to go. Okay, and when you double click on that file, you should show up on a screen. I mean, at the top of your screen, you should see something like this. Yeah, using databases with Python. Okay. So I've tried to structure this as a document that's fairly self-contained, so you should be able to read it. Some of this we've already discussed, so let me switch immediately to the most important part. If you have any questions, it will be hard for me to troubleshoot anything, but follow along as I give you a live demo. And then if you have any questions, just reach out to me and we can make sure that you are able to run all this properly. Okay, so the most important thing here is to study about relational databases interactively, as we like to do, we need to actually have a database. And it's really a very nice thing for us to be able to use a database SQLite. I don't know if some of you have used it, but what is really nice about this database is that it's a lightweight database and it can run essentially in the process. It can be created dynamically. It doesn't require any configuration or setup or anything. So you can just launch this database, write to it. And then when you're finished, you can even save the database down to file. And it has all the properties or all the reasonable properties of databases. By the way, it happens to be heavily used and embedded in all kinds of apps and everything. So it may be one of the databases with a large number of installs. Again, I put links in here for you to go and read a little bit more about this database. I myself historically have been using other kinds of databases like Oracle and SQL Server and other things. So this was just interesting to explore this particular database, okay? And there may be reasons later on for you to upgrade from this database to other ones and so on. But for today, we are good to use this database. And our goal is to, as we discuss this problem of students' grades, let's just go ahead and start creating that database, okay? And then we can do some data insertion and analysis on top of it. So the most important and simple thing here is you want to connect. Yes?
There is a question on chat, some comment on chat by Mitch.
Yes. The information isn't in my copy. Which one, Mitch? Can you give me some color? Which information? Okay, I will wait for Mitch to respond. Okay. Are you looking at this file? Using databases with Python? And are you saying there's some detail which is missing, or are you saying this particular cell is not there? Oh, okay, okay. Okay, so let me just, so I'm actually using a notebook locally. I might have added some extra things for my demo, but since all of you are raising this, let me just follow along with you. So I should be able to open this. Thank you, Mitch. Thank you for pointing that out. Okay. Okay. Yeah. So here you can go directly to this section, connecting to a database. Hopefully all of you are seeing this. Okay. Excellent. Excellent. So this, so please use this. I think I have, as I create this material, I have added and subtracted lots of things. This notebook should give you everything you need. Please interrupt me along the way, okay? I will continue to use the notebook that I have been playing with locally, etc. It's an interesting problem, right? I work with a notebook locally, and it's very hard for me to keep it synced up with the cloud. Okay, so anyway, so the key concepts, and please interrupt me if anything that I say here you cannot replicate, okay? It should be pretty much identical, at least concept-wise, okay? And thank you for interrupting. That's very cool. So the important thing here is, let's just talk about a couple of things here. Import SQLite 3 as SQL 3. Okay, SQL 3 is just a namespace, as we have been doing. Whenever I import things, I like to import it into a namespace. SQLite 3 is interesting. That's what the Python library is called. It is given this particular name because of SQLite version 3. Okay, so you can just do this import. Now I have imported a couple of additional things here to make our code display nicely, etc. Please ask me later and I will talk about these two imports, okay? But let's focus on the SQLite part of this discussion. So the $1 million thing, right? If you have a database, you should be able to call connect, and somehow in the connect, you should be able to pass some information that allows the connector to connect to the database. It's called a connection string, right? And in this particular example, the database will get created or is stored exactly in the same folder as this particular file. And so all I have to do is to give it a name. Typical convention is to name it with a .db, okay? So you know it's a database file. And then after that, it's a black box, right? I mean, it's a file that SQLite will manage and store appropriately, etc. So the beautiful thing about this SQL connect is when you call this connect, if the file does not exist, it will create it for you the first time. And the second time, if the file exists, it will automatically use that database file. So for one way you can just eliminate the database is just delete the file and start again, okay? But there's also ways inside the code using SQL to delete all the tables and so on and so forth. So this is the basic idea, connections. Now, I will just make some small comments here. When you change your database, you will have the same metaphor. There will be a connection object and you will typically call connect using a connection string. And these connection strings can be different depending on the database. The database might be on a different server. There's a particular path to get to that server, etc. So when you want to connect to a database, I guess one of the first questions is, where is the database and what's the connection string? Okay, and then once you connect to this, when you call this connect function, you basically get a connection object. And when you're done doing all your work, you close or you dispose of this connection resource by saying close. Now, today we're going to have a few instances, since we're managing persisted resources, we're going to have a few instances where we have to explicitly manage the resources. And so we have to make sure that we call close. For example, these connections can keep open database connections to your database. And eventually, if there are a lot of people or a lot of applications connecting to a database, if you don't close the connections, you start saturating the number of connections the database can handle, right? So, and we'll talk about managing connections as well later, but for now, we are ready to get started, right? So you can just connect, and when you're done, you just call close. Okay, so the next important idea is the notion of a cursor. And a cursor is something that you create by asking the connection object to create a cursor. Now the cursor is really the workhorse for us, right? You should think of it as something that you can actually use to execute your SQL, to interact with the database, but it's kind of a thing that does not get populated until you go further. So let's just try to use it. Just think of it like a pointer to potential data, okay? But we'll see this explicitly in a minute, okay? So you ask the connection to give you a cursor, and then you can start using all the SQL that you know. So what do I mean by that? So let's start off by saying, okay, if we have a database, then we should probably want to create a table in it. So here is the way that you would create a students table. Okay, so for those who know SQL, this should be fairly standard. But basically, we are saying create table. notice that you can use the if not exists. Okay, this is going to be an interesting thing for all of you to ponder. Like if you try to create a table and table already exists, then it will give errors and so on. So this takes care of all that. And then you design your table appropriately. Now, I have done a very lightweight table design. Okay, I have not done much, just kept it very minimal. This is a big topic on how you want to design this table and all the columns you need and so on and so forth. Okay, so when you run this cursor, yeah, so my database is closed. So make sure, hopefully all of you can execute it.
Yeah, I think you commented the wrong line. So that other line should be uncommented.
Yeah, I did. I should have closed it. Yeah. Thanks, Amay. Okay. So now you see that the cursor is actually an object which comes back, and the table has been created in the database. Okay, so obviously one way to play around with this table is to insert some data into it. So you can use a SQL insert statement, and you say insert into table, and then you pass in the column names that you want data inserted into. And then you have this particular construction. I will talk about this construction in detail in a second, but if you run this thing now, you should have data inserted. Okay, yeah, because I need to make sure that I don't have, yeah, I've already inserted data in here. Okay, so can all of you just make sure you can run it? And if you have any trouble, just let me know. Okay, so I'm actually able to insert data into the table. Okay, so just make sure the problem error I got was that I had already inserted the students, and I have a unique constraint on the ID. So I'm trying to insert the same ID again, and then it fails. Okay, so if you're bulk inserting data into a database, you should make sure, yeah, you should make sure that you're not duplicating records, etc. Okay, so now let me just talk about this insert construction, right? So the important thing here is whatever we pass to the cursor is actually a SQL string. It's a valid SQL string. And the SQL string needs to have variable parameters in it, right? For example, it needs to have the student name or the student ID or the student email or whatever. And you can actually build strings by using string concatenation. Okay, so there's a lot of work here in constructing the SQL string appropriately in your program, so you can actually post data to the database, right? So building SQL becomes a small technology in your application. Just for amusement, I don't know if you'll find this funny, but you can just read this XKCD cartoon. If you understand this cartoon, you've understood something interesting. The idea is that when you build strings, you have to be careful of what are called SQL injection attacks. And SQL injection attacks or failures are when strings that you don't really intend to get created. And this cartoon says that if a student has a very funny name, Robert blah, 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 which is half a SQL statement, then if you try to insert this student into a database, it will actually delete the entire table, right? So this is prevented in a couple of different ways. I spent 20 minutes just playing around with SQLite and seeing how it handles this. One of the nice things we do here is we say execute. This executes only one line of SQL script. So if somebody injects multiple lines of SQL, this execute will fail. It will say there are too many lines and won't execute. But if there's a command called execute many or execute all or execute script, which will execute multiple SQL instructions, and then these kind of things become relevant. Now, one quick way to bypass all that discussion is to use this construction. And this construction will take care of making sure that only values are inserted and so on and so forth. Okay, so spend a minute just to master this syntax. It's probably a good thing to do. There are a couple of other options, but I found this the neatest way to construct an insert statement. Okay. Okay, so after you're done with this, we can now go and do the next part, right? Okay, so we have put data in the database, but we can't see it. So then again, we go back to SQL and we say, okay, we want to execute a select statement. And obviously here we want to do select star from students. So you can just, as you're starting to see now, the cursor can execute anything. And if you do select star from statements, you get back a cursor. Now, the real question is, does this cursor have all the data in it? And the answer is no. The cursor is not going to pull the data. It is aware of what the result set for this query might be, but now you need to pull the data. And there are many different ways to pull the data. Today, because our data is small, we will just use the fetch all part construction on the cursor that will fetch all the results. But there is a way to fetch one, to fetch many, to page the data and get 5 records at a time, etc. So there are different options, okay? So if you run it, you should see something like this. And what have we done? We have created a SQL statement. We have executed it. We've asked the cursor to fetch all the records from the database. And now the magic of my print results function. So the print results function is a very simple function. It's basically going to tell you, okay, so let me just open this up quickly. So I put some of these utility functions in this file. So if you look at print results, it's fairly simple thing. It basically takes the cursor object, and then it basically goes through it, right? So you can iterate through. So this is the part I want you to focus on for now. It iterates through the rows of your cursor, and then you can do whatever you want with each row in your cursor. Okay, because the cursor has got execute all, it basically produces a list of records, and the print is basically just looping through the records and printing. So what is the rest of my code in this print results function is basically, how can I get hold of the columns? Okay, so if you because sometimes you want to know what the columns are. So here, for example, I've tried to print out what are the columns, and the columns are retrieved by asking the cursor to give you its description. Okay, so cursor.description actually will give you the columns. Okay, one small trick, so you can basically, when you're doing this, you can always just, open in the notebook. So the nice thing about the notebook is you can add an empty cell and just say cursor.description, for example, here, right? And you see, you can explore whatever's going on. So I want all of you to move into this interactive mode as you get familiar with this whole thing, is to run stuff, allow it to break, see what happens, reason about it, etc. Okay, so cursor.description is a strange structure, but what is interesting to us is it's a tuple of tuples. But what is interesting is the first column of this tuple of tuples contains all of the column names from the table. So it's basically taking the metadata of the table and pulling out the column names. Okay, so by combining the cursor rows and the column names, I'm able to create a fairly simple display, right? And show that there are records actually in the table and pull it back and so on. Okay, if you want a slightly better, okay, I like a little bit something to be easy on the eyes. So if you want a slightly better view of the same data, you can run this function called display results. Now that is a small homework exercise for you. Those who are advanced will find it trivial. But essentially what I've done is I have done the same looping through, and then I have created HTML. And the Jupyter Notebook allows me to display the table as a HTML table. Now this HTML display will be useful for those who want to build apps and websites and so on. But for now, you can just use this display results, at least in this notebook. So you get a slightly nicer view. I do want to highlight though this idea of when we want certain functionality to write small functions that will help us to keep moving forward, to clean up our working environment, give us nice displays, all these things really make your life better. And also, your skill of taking 10 minutes and writing something that you can reuse potentially is probably very helpful. So if you do this naturally, wonderful. If not, start flexing that muscle as much as you can. Okay. So, so that's all that's done. So now let's just do the hard work. Okay. The hard work now is I want to basically create the entire database, right? And which database? The student grades database. Actually, I will just pause for a second and ask you, did anybody have any questions about the structure of the student grades database? Since all of you are SQL experts, I assume that the structure of this database is fairly clear to you? Can you tell me in chat? Do you guys understand? I can just go ahead and start creating things and querying things. Someone in chat? Anyone? Okay. Okay. Yeah, the reason your notebook is a little bit different is because I put some extra stuff to maybe illustrate the points more. I'm happy to walk through this stuff as is as well. Okay, so let me just follow the notebook then, so that makes your life a little bit easier. But my question was more importantly, before I focus on this notebook then, my question was more importantly about the structure of the database. Is everyone okay with this database structure? Are there any questions about why it looks like this? Why would we have this particular set of tables? Okay, so at least Christian says, yeah, it makes sense. Clear. Okay, excellent. Excellent. So then that's beautiful. So then I can just move on. Okay, so let me just say, so here I put in some basic SQL information for all of you, for those who are new to SQL. Let me just touch on them quickly. You guys are all SQL experts, so I won't spend much time. So they're clearly to select data from a table, you have the select statement. And what is interesting is that instead of saying select star, you can also specify what is called a projection. You can select only the subset of columns that you're interested in. And then there is, of course, a where clause, which is very, very important. The where clause allows you to filter all the records that come from the database. So if you are not, for the few people who need more practice, use this as a good way to write different types of queries and just play around with SQL. When I was learning SQL, it was very helpful for me to have a database where I could run queries and play around with stuff, right? So the where clause is very important because you can actually have the database, the database is optimized for manipulating the data in the tables. So running filters and so on the database can be very efficient because the database has an index on the table potentially, and so these queries can be really fast. So you can use the where clause to do various kinds of filters. There's explicit filters, like you can match on first name or something. You can do like regular expression like filters where you have the SQL like clause you can use. And then you can also sort and order the result sets appropriately, right? So you can just say order by last name, ascending or descending, or multiple columns even, right? And eventually we can even talk about group by. Okay. So much for basic SQL and single table stuff. I was about to transition into this multi-table discussion. Okay. So here is the multi-table structure. Please make sure that many of you have said it's clear. So, but if anyone is not clear, please make sure that you reach out to me and make sure even though this particular structure is simple, the ideas here are very powerful. Okay. And you can do some really cool things with it. Okay. So what do we have to do now? Now we want to start creating this database. And what is nice with this Jupyter notebook structure is the font okay? Okay, I'll just make it a little bigger. With this Jupyter notebook structure, you can actually start manipulating interactively, right? So here we have created a table, then we can insert data. And now, you can select data, you can see the data coming back, okay? Now I want to tell you something about the notebook structure here. This is nice for us to play around with the database as we are creating it. Eventually, when you want to mass produce this database and have an automated script, we will transfer all this into a file and run it. And I've done such an activity for you in the labs. So we will go and look at that file quickly before we exit this topic, okay? So since all of you are familiar with the database structure, you can see that I just proceed to create the other tables. Okay, so for example, here I create the graded activity table. This is the mapping table from students to courses. and eventually the most important table, which is the student grades table. Okay. And now this is something you won't have to do typically, but I have to do for this particular course. Is we have to insert data into this table, and I don't have an actual students database I want to upload in here, or actual student data. So here I have just generated some sample data. Okay. And you can, I don't know whether you should get in the technology of creating sample data, but the ideas of inserting data into the table, looping through collection. So you could imagine that the sample data is actual real list of students, for example, and then you can start inserting data into the table. Okay. So this may be a good exercise for you here. I'll just pause and spell out the exercise. You could just, after you have created the tables, figure out how you can insert data into all these tables so that there is a sensible structure of data in your database. So once the data has been inserted into the tables, the next important idea is, okay, we carefully designed this database, we have split up the data into multiple tables. We probably need to join them to bring the data together, right? And of course, there's the whole technology of joins, right? And for this construction, for today, we will focus on what are called inner joins. So if you take two tables and you try to join them, then you have to specify what is the key that is used to match records between the two tables. Notice that the key has to be fully qualified, right? You have to do table name dot key name, and then you can join them. And the idea of the inner join is that only records which have matches on both sides will be returned. Okay, then there's a outer join and a right inner join and so on. So there are various kinds of joins. It's not very hard. It's just many ideas to keep track of. I will not emphasize the other types of joins. Again, we can discuss that if you want to. Okay. But we are in business right now. We are interested in inner joins. So you can actually join, you can join on whatever criteria you need. In this case, I've used the student ID as a criteria to join it. And then you can start creating reports, right? So this template allows us to create various kinds of reports. What is the obvious report you might want is a report that says, tell me which courses does a student belong to, or which students belong to a particular course. And you can accomplish that by a already you can see this is getting a little tricky now. It's a 3-table join, right? So you have 3 tables here and find the right keys to make the join and construct this, okay? So less for me to talk about, since you guys know SQL. I hope this is all easy for you. If not, don't let me rush off and interrupt me or slow me down, and I will walk through anything you want here. But the whole idea is that for you is create the appropriate SQL statements. You can run them. And I have created now here, I can say, I've created a small function called execute SQL, which is also in that file. So if you want, you can read how does this particular function work, okay? So it's also part of the, mindset of saying, you know, whenever we want, so I'll just show you, here is execute SQL. So execute SQL basically executes the SQL that's given. It calls fetch all on the cursor, and then it calls display results. So you can see how the functionality has been built up by chaining small functions together, right? So that when I'm working with my actual code, you don't see a lot of stuff here. So refactoring your code to make it clean and precise like this is a big Python skill, right? So then after this, I can focus all my energies on constructing the SQL. I don't have to worry about displaying it and looping through stuff, etc. So when you create your applications, that's a great code design skill, right? To focus your code or bulk of your code on what is essentially not automatable, right? The minimum stuff that you need to have, okay? Okay, so we've got this now. Now I have inserted some grades. I've inserted some grades into the graded. First of all, I inserted some activities. So the idea with this graded activity, it's a little bit the way I think about design. I'm sure there are different designs for this possible. Because I was unable to come up with a common name for quizzes, projects, labs, etc., I call them graded activities, in the sense that at least all of them will have a grade. And then there are special instances of a graded activity. So in this case, there's a graded quiz, right? And then I allow for them to have different weights as well, which is a mildly advanced capability. Okay. I encourage all of you to tinker with the design itself. There's no reason why this is a God-given design. Okay. So, and if you have any suggestions to make it more interesting or more challenging or more fun, just let me know. Okay. So once you have inserted data, of course, I should say, as we start inserting a lot of data, you might want to delete stuff, and you can just delete by saying cursor.execute. Again, it's a SQL command. So notice this, the whole emphasis here right now has been, if you understand SQL well, you can use SQL to manipulate the data right inside the database, right? It's not about pulling a lot of data out and then writing a lot of code. Later, we will talk about, okay, if I just want to use the database as a store for data, I want to pull the data into my code and manipulate it. We will start doing that soon. Okay. So now we have inserted. So in this example, I've inserted a lot of scores into the scores table, and you can start pulling this all back, right? And now we start getting into, so the database is pretty much populated at this point. So the courses are populated, the students are populated, the activities are populated, and now the grades are populated, right? And you can imagine that as a nice workflow for designing an application, right? That allows people to upload Excel spreadsheets for grades or something, and then store everything in database, okay? Or key entry data into your application, right? Okay, so once this data is all in here, then we begin to switch gears and start thinking about pulling back data and or writing reports and or doing analysis on subsets of data. And so one important thing that is possible is construct nice SQL queries, right? So that you can carve out the explicit subset of data that you need. There's another extreme option which says, no, I don't want to spend time on SQL at all, and the database may not even scale, so I will rather pull everything out, and then I will manage everything in code, okay? So an example of the pulling everything out is when you write a query that looks kind of like this, right? So I have joined 5 tables here, almost all the tables. And then once you get the data, you can pull whichever columns you want, and then you have a big set of data. Now you see the power of the database is that obviously data is replicated here, but it's only replicated on the fly, right? And so you can use and throw it. And if you make update to a single record in the database, for example, if you change the course name, the next time you run this query, everything will get updated, right? So again, rather simple thing at the end of the day, but extremely powerful thing that you can actually manipulate data in multiple tables and have your cake and eat it, meaning that the data is maintained and persisted at a granular level, reflecting the structures that are naturally present in your data. But when you join the data and pull it back, you can create structures which are relatively flat, and then you can manipulate in your code as well. Okay, so that's in a short nutshell. That is basically everything you need to know about SQL for today. But I want to just flash you through quickly to the labs. So if you go to our website, and if you go at the bottom, sorry, let me see if I can find, yeah. So if you go to session 6, you should find a lab section in there. Yeah. So you see that 6.4, there's a lab in here. And if you click on this lab, I can just walk you through a little bit of the instructions and also just the layout of things. Okay, so the lab here, if you click on this view resource, a new window will open up, a session for you, which looks like this. Let me just talk you through a couple of files in here, and I will come back to the actual assignments. So just to show you, since I showed you everything in the Jupyter notebook, this single file will actually create and populate an entire database, right? So you guys, if you're interested in this, you can actually read the details of how the database is getting created for you. And that will teach you some SQL and some manipulation of data, etc. definitely come back to me with any questions you have. But the work that we want to do in the lab is actually what we want to do in this analysis.py file, right? And this particular database is actually interesting. On CodeBoard, I'm not able to persist a database across multiple sessions. So we will dynamically create the database, use it for a session, and dispose of it. Okay, and it's a tricky operation, but I've tested it a little bit. It works. If you have any problems, again, please be patient and reach out to me, and I'll definitely respond and help. Okay, so let's look at what we want to do in the labs. As you can see, the labs is mostly about analyzing this data, right? And for those who are good at SQL, it should be fairly easy. A little combination of SQL and code will get you home. Okay, so try to pull some minimal set from the database and then try to use Python to manipulate the data that comes back. Okay, and then if you can do this, I think you're in a, if all of this is clear to you, I think you're in a very good place, right? Which means you understand how to design a database, you understand how to pull records from a database, you understand how to manipulate the data, build reports, calculate things, and you can be in a very good place. My entire effort was to make this as concrete and hands-on as possible, right? Even though I made a few theoretical comments here and there, okay? So please dive in and start typing code and asking questions, and hopefully it is fun. So I am going to pause and I'm going to switch to file IO. But how about we take a minute and see if there are any questions that you might have. Any questions about the topic, about labs? So far, so good. Okay. You guys are great. I mean, it's very hard to show you something that's too, that's too difficult. Okay. So I am going to, anyone else other than Christian? Anyone else, any comments on the subject material? Yeah, all of the labs are available. So you should still be able to, yeah, access them. All of the material should be available, yes. Okay, so it's a good time, I guess, to switch gears. Now we will switch to the next topic, right? So if you go back to here, so you can just open this other file here, which says file IO with Python. Okay, so now we switch gears and we talk about a slightly different approach, right? But clearly the older approach, and in some ways maybe the more robust approach, which is to use files. But of course, the only downside, as I will highlight quickly for you, is that very quickly we will start encountering the special characteristics of files, right? You will couple closely to the data, the structure of the files will become important, etc. So, okay, so let's get started. So the first thing we want to know before, and some of these topics I cannot explore in depth, but the first thing we have to deal with when we say we want to deal with files or write and read from files is we have to ask the question, what is a file format, right? And so the details of the file formats become very important. And what are some of the aspects of what I call a file format is, for example, what is a character encoding, right? All information. Let's talk about, we're talking about textual files right now. There are other kinds of files where we store binary data or image data and so on, or image data as binaries and various things. So today, just to get started and get some traction, let's focus on textual data, okay? So if you're doing textual data, then you must ask, how are the characters encoded? And there are clearly two popular character encodings, either ASCII or Unicode. Again, I won't have any time to do justice to these two character encodings and the history of character encodings. I think it's a very beautiful subject and you should definitely explore this on your own. Of course, if you have questions about them, do come back, okay? The next question, just to give an example of the kind of problems that we will have with files and how we need to couple closely with file structure is, for example, if there are line breaks, what exactly is stored in the file and how is a line break represented? And already historically, there was this big clash between different choices for line breaks. And this is why files, when we copy them from one type of operating system to another, the natural line break character is not the same, then files will get mangled and so on and so forth, right? It caused a lot of problem over time, especially when people were using files very heavily. And it is a very clear example of where relational databases liberate us from all of this low-level stuff, as Cod was trying to suggest we do, right? But anyway, now that we're reading files, you must be aware of all these ideas. Also, when you're writing to the file, you must be aware of what kind of line break character you want to use and so on and so forth, okay? Then that's that at the end of the line. So think of a file now as the tables in our database, but just a bunch of records. Each record is like entries, like a tuple, multiple values. And we have to ask the question, okay, how do we want to separate these values, right? And so there you can use commas, you can use tabs, and any other character, pipes, various things. So again, you can see what's the tedium of files is that you must be aware of and able to handle all of these different separator criteria, right? So for today, we will talk about comma separated values, tab separated values, okay? But space separated values, there are various things you can create. Comma separated values are kind of natural. Those who work with Excel spreadsheets, etc., they have natural exports to CSV formats and so on. So that makes it easy, okay? And then the last thing that we have to worry about, this is all a minor detour into file formats, right? I mean, making this into a very well-ordered structure is very helpful when you want to parse files. The next thing is, okay, are there header rows, right? So people might put information at the top of the file, typically information about what's in the file, potentially information about the columns, how to interpret the data. And so when you're parsing files, you must know how to handle these header rows. And sometimes you might even use information from the header rows to enable you to read the file more effectively. Okay, so that's all. I mean, it's stuff I'm saying, but it's really important, right? When you want to get some work done, all of this must be well organized in your mind so you can start writing code, okay? But for now, let's just start doing the basic mechanics, right? We should open a file, we should write to it, close it, okay? That's some simple thing that we want to do. So here's a simple example for me of writing to a file, right? So you can create some data. So in this case, I've created a list of 10 elements. Then you pick a file name. Okay, so I'll spend a minute here. There is a side trajectory here that, again, I encourage you to explore on your own. Files live in a machine in some kind of file hierarchy. And so there's a lot of tools in Python to manage that whole file hierarchy. Whether you want to set up paths, or you want to navigate folders and directories and trees and so on. For this discussion, I'm basically saying that, of course, if the file lives in the same folder as your script, then life is the easiest. If the file lives in other folders, then this should be a full path. But this path, now it gets tricky. This path must be relative to where you're running the script from. And that becomes a whole technology, right? Where will you run the script? Will it change where you run the script from? What is in my path? What is visible, etc. So I don't want to just go down that maze of complexity. For now, let's just keep the file locally, okay? And then understand that if you want to move the file to some other place, you should have a clear path to get to the file, okay? Once you have this, you can create whatever name you want. The extension is whatever you choose to. The extension doesn't play any role except if you're going to use the extension to tell you how to process the file, okay? And then we start the work, okay? And so just like we had a cursor in the database case, so the basic function we want to use is this function called open. You pass it a file name, and then you have this optional parameter, which you can set in different ways. So right now, by default, if you just call open by default, it will open a file for reading. When you set mode equals W, this will open a file for writing, right? So if you say open file name and you specify the mode, you will get back, just like you got a cursor, you will get back an object, okay? By the way, for the next, I just want to put a placeholder for the next class. We will talk a little bit about objects in the next class. I've been holding off on objects, and next time I'll explain why I held off on objects a little bit. But we will talk a little bit about objects and how we use them and so on, how we create them next time. Okay. But really what you get here is an object. And then we can call some methods on this object. So for example, here I just asked Python to tell me what is the actual type of this object that I just got. And you can see it's called a text IO wrapper. Okay. So think of it like the cursor. It's a thing that is capabilities. And one of the capabilities it has is the ability to write. Okay. And so all I do here is, or all you will do in general, is loop through the data you want to write, construct the actual data you want to write, and then write it. And here what I'm doing is writing line by line, right? So each element of this list gets its own line, and at the end of the line, I've added the new line character, okay? And then once I'm done with writing, you call close, and then you're done, right? The file will get created for you. It'll have the data. So you can just play around with writing different kinds of data. Now here I've just put one value if you want to put comma. So the trick here is constructing, just like we constructed the SQL string, the trick here is to construct the string that you want to write to the file. So again, I will put a placeholder for next session. In the next session, we'll spend a little time talking about text and string manipulation, right? Again, for various reasons, primarily to get you to the interesting topics of data science and relational databases, I've held off on a very fundamental thing, which is strings, but we will discuss that again next time. Okay, so at the end of the day, you build up whatever string you need, and then you can just write it. Okay, and now there's an important thing. We would like to make sure the file is closed. If the file is not closed, there could be situations where, you know, some other later you want to open the file in another program and it says the file is locked, and so you really don't want to keep any resources, databases, files, other things open longer than you need it. And when your program is complete, it is good practice to close it, because there will be all kinds of unintended side effects otherwise. Okay, so general principle, when we acquire resources, we should make sure that we release them once we're done with it, right? Maybe a good life practice too. But because this is a very standard pattern, so where does this pattern break? This pattern breaks in two places, right? One is if I forget explicitly call close. But the more insidious problem is if I have an error in my code, and the error, you know, as soon as I error on this line, it will jump out and will never hit the close call at all. It will jump out and maybe crash my program, and the file will never get closed. And so there are two approaches to handle this. One is to use exception handling, which we haven't discussed. So I'm not going to talk about exception handling today. Again, this could be one more topic. So I've listed about 3 topics for the next session. All of them extremely useful and relevant, right? How do we handle errors in our code? But there is because this pattern of acquiring resources, so there's a classic paper, I forget the details of the paper. If you're interested, you can let me know. There's a classic paper which came up with this moniker, which says resource initialization is resource acquisition. And in this paper, they talked about this idea that when you initialize the resource, if there was a good construction that allows you to release the resource as well, right? And that construction has now been encoded in many languages. So if you're working with other languages, Java, C#, many languages have this construction. So there's a very nice construction. You do a with, so this is called a context, right? And you're basically creating a context. So you essentially rewrite that code in a slightly different way. So how does a context work? You use a with statement. And the with statement allows you to acquire a resource, right? And this part of the with statement is defining the resource that I'm acquiring. And then you have an indented block inside the with statement. And this indented block is the scope in which this file handle and this resource will be kept active. So think of it like a for statement, right? As soon as you exit this block of code, then the file handle will be automatically closed for you, right? So this is a very powerful metaphor, very relatively widely used by now. And of course, if you've seen it before, it's obvious, and it's good practice to write your code this way. It will take care of the problem that if your code crashes, it will clean up and so on and so forth, right? And it's a little bit cleaner than using try, catch blocks and so on to manage this. So again, just a metaphor. Once you learn it, you might start using this, and you can even use this, go back to your database code and use this metaphor even to manage cursors and various connections and various things. Okay, so for example, you could do with and open a connection and then use it in the context of the with block. That's a nice style of writing the code. Okay, so this will also do the same. Other than the way the resource is managed, there is no difference between this code and the previous code, but I would encourage you to use this format. And then of course you can start writing small functions, right? So I usually, when I work with files, I mean, this is just the thing, I abstract away some of the ideas. So for example, maybe I just want to pass, you know, a file name to a function, and it's responsible for writing something to the function. So I can say file name comma data, really, to make this full. That's what I meant to do, right? So you create little small functions like this that will, again, it's essential that you create these small functions, because after you created those functions, you can hide away from all the details of acquiring resources and closing and so on, right? Just pass data to some function and say, please take care of writing to the file for me. And then you can focus on whatever your work is, right? Which is primarily managing the data. So that's just a little design guideline for you in terms of file handling. And the reason I'm saying this is the logic that may be needed inside this file can be complex, but should not, once you've understood it and done it, should be encoded once and not repeated multiple times in a code. And it is easy to do this. So it takes a little work to disentangle this writing file IO part of your code into a separate function and then use it like that. Okay, so now we know how to write to files. I think it's all downhill, easy from here. So now we just want to read from files. Okay, so if you want to read from files, so now I can emphasize this idea. The file mode was created essentially for this idea that there are different processes that can be used to read and write to a file, and they can be optimized appropriately. So if you're reading from a file, you're never going to write to it. It can be optimized for faster reads, etc. Okay, so the only change you have to make to read from a file is you call open, but by default the file mode is set to read. Okay, so if I delete this, I like to keep it explicit, but if you delete this, it will just open for read as well. Okay, and then you can just loop through the file. So this is important. The file handle in this case is like the cursor again. And just like we could loop over the cursor and go through the rows of data coming from the data, after you call fetch all, the rows of data coming from the database. Here, as soon as you open the file, you get a cursor or a file handle. And now you can loop over this file handle, and then each time you will get a line from the file handle, okay? And then you can manipulate this line. What you might need here, and I've actually used this, is when you get a line, here's where you might want to split that line on some criteria. So the line comes to you as a string. If you want to break it on commas, you just call line.split. So here you could do something like, so this is just one function. We will discuss these splitting functions and string manipulation in detail next time. But you could say line.split on comma. And if you do that, it will give you basically a list of values in a list, okay? Where the commas are, it will get split out. So just write a small line of code and test this out, line.split, and you should be good to use it as well if you want to split. In this case, I didn't need a line.split because I had only one column, okay? But if you have multiple columns, then you might want to use it. So here's a good example. We're going to use this. I will segue to the assignment, to the lab in a second. We're going to use this company data.csv file just to give you a small example to play with. So you can see that this company data.csv file has some data in it. And your job is to basically parse this data, read it. By parse, I mean read it from a file, and then you can manipulate this data. Okay, so if I quickly switch gears and show you what you have to do in the lab, in that particular exercise, the file is already uploaded on the server for you. You should just be able to go to that file, read all the data, and then a fairly simple exercise to compute the aggregate profit for all of those companies, and then find a company with the largest annual profit. Okay, simple analysis. But hopefully you can see how these little patterns can generalize and also apply to very real data. Okay, so I've tried not to complicate our discussions by the complexity of real data. There's always something extra and complicated when we start downloading real data, right? So hopefully this part of the lab should be easy. I will just show you where this stuff resides. So if you see here, you should see this company data.csv file is already on the server for you. And in this analysis.py file, you can just implement this. I do want to say to you that just to highlight, and I won't even get into details of this, you can see that it's fairly complex to construct the path of this file on in a virtual session like the above. Okay, so you just use these paths, and these file names have already been set up for you, so you're pretty ready to write your code and run it. Okay, so much for file I/O. I have to say just one more important thing though, and again, you can spend more time playing with this. Clearly, there is an important thing here about, okay, these are text files. What about other kinds of files? So for example, binary files, and the mode option here is helpful. By the way, you can do something like this. You can say help and just say open, for example. And it is a nice feature that if you run that, you get back the Python help documentation. Okay, so it's a nice way to explore when you're working with code. If you need information, how does something work, etc. This may be a good moment for you to switch into looking at the documentation, reading a little bit more. Clearly gives a lot more detail than I can possibly talk to. But here, let me just explain. For example, here are the modes that we talked about, right? So R for read, W for write, B for binary mode, right? So you can combine these two. You can do BR, so that will be open in binary mode for reading. Okay, so you can play with other file formats, but of course, I would suggest right now spend all your time on the text format. Okay. Yeah, so in a nutshell, you are now masters of file I/O too. As we go to other libraries, there will be other ways to interact with files. This is the kind of lowest common denominator, most transparent way to work with files. So if you have questions about other things or special scenarios that you might want to read or write from files, just, of course, as always, reach out to me. Okay, so let me pause for a second. Any quick questions on files? Everything's easy, clear? I'm watching chat, so if somebody wants to share. Seems clear. Okay, at least one person. Anyone else? Thank you. Okay, excellent. Yes. So at least the two of you, I think you're speaking for the rest of the group. This is right? You need time to sit down and type and think and so on. But I want to share with you that this part of the course, this particular session, is an extremely useful session. I think as you go on forward into your lives and careers, you will probably look back and find numerous places and instances where you can use these ideas very effectively. I myself have spent many years working with very large databases and storage problems. It's always challenging, right? If you want insights into what kind of problems are out there, I'm happy to share at some point, but maybe not today. Okay, so let me just start winding up. I just want to give you a quick summary of what we did today. We covered two important techniques for persisting data. One of them I like very much is relational, the idea of abstracting away details of storage and using relational structures. By the way, there's also a mathematical aspect to it, right? I mean, there's a relational algebra and a relational calculus on which all of SQL has been constructed, right? So there's a beautiful mathematical structure. Even the structure of relations is driven from set theory and so on. So it's an extremely elegant piece of technology, right? And we could spend many, many hours understanding it better and more. And then, of course, files. Again, you know, if you think about all the data that is persisted in files, I mean, it's an amazing resource for us. Okay, so what? So please, yeah, definitely spend the time, learn how to use it. It would be wonderful if you guys are in a place where you can just look at your data and think about the data, and all these details about how to connect to a database or how to write a file are just trivial, right? So you can focus on the real problems. Okay, so what next? So I just, you know, kind of the tip of the iceberg that we have seen. So let me just talk a little bit about, you know, what is the rest of the iceberg look like. So clearly, database design, right? I mean, already we have a 5-table database just to store some student grades. You can clearly see that when we make this more industrial strength, choosing which tables to create, how to join them, what keys to use, what is the relationships, how much to normalize the data. By normalize, I mean splitting it from one table into smaller tables. There's a whole hierarchy of what are called normalization schemes. How do we make sure that data doesn't get corrupted? So there's referential integrity strategies that will force you to, you know, do certain things when you try to insert data in the database and prevent the data from getting in an inconsistent state. A very big problem topic, very hard, very worthwhile solving, is understanding how to version data. So changes happen in the life of which gets reflected as changes in the data. And for many applications, you might want to go back and see how things changed. And so you will have to store multiple records and keep versions and so on. And it's very non-trivial problem to solve in databases, right? So having good versioning strategies and having optimized versioning strategies. Databases also come with what are called store procedures. So you can take SQL and package it. And so store procedure technology has gotten very powerful these days. So for example, you can actually now even run Python inside the database and or Java or such things. You can embed Java alongside with SQL. And this may be part of your thought process. You must start to ask the question, what things are better managed in SQL and what is better managed in code, and what is better managed on the server and what is managed offline, right? But anyway, using store procedures is a very large topic here. Data encryption, right? Data that we store in databases, passwords, various things, it may not be sensible to keep it unencrypted. So how do we encrypt and decrypt data in databases and make sure the data in general is secure as well, right? So these are all kind of, you can say each one of them can be a separate lecture in its own. Depending on where your career is leading you, you may want to, you know, explore this further, okay? So then the next idea is that, okay, calling connections and cursors is one thing, but can we actually work at a higher level than that? And so there are some ideas here, again, big topics. There are things called object relational mapping packages, object relational mappers that will actually query a database, pull the data back, and instead of giving you cursors, will actually give you collections of objects. And so if you're working with objects in your code, you may be more interested in just taking an object and then designing a screen to display it or something like that. And there's a lot of stuff here. Again, very complicated, little bit abstract. Of course, you can take a practitioner's point of view and start using them. If you're interested, let me know. I can suggest some packages, etc. Again, at the same level of abstraction, the other idea is that I don't want to even see a database. I just want to call a service. Service should hide all of the details of the database. Now, databases hide the details of the files. Services hide the details of the databases and potentially even more logic. And so this whole field of what is called service-oriented architecture. By the way, what is nice for you to know is that you can build these services using Python. Okay, and as these services got big and gigantic, people started a new revolution called microservices. Actually, it's very interesting. You can quickly spin up a Python service in like 10 lines of code and have it feeding people data or getting data from people and doing analysis and so on. So all of these are like abstraction layers, right? And then there's also very powerful data virtualization technology that allows us to put a layer of code around multiple databases and join across databases and so on and so forth. So again, these are all huge, very powerful and complex pieces of software, but it's good to be aware of them at least, right? Even if you're not actively using them. Maybe at some point, understanding a little bit about microservices is probably practical today. Then there's this whole discussion about scalability, which again is a performance type of question. But if you're Amazon.com and you have millions of customers, clearly a SQLite database will not do it. But even if you buy the most powerful database engine, Oracle or SQL Server, it still runs on a machine, can support only X number of connections. So how do I support millions of connections, etc., right? And that leads us to a whole bunch of ideas that we use to get reliability and fault tolerance, right? How do we split databases across multiple machines? How do we deal with failure of one database engine, etc., etc.? So, and then of course, every time we hit the database, how do we make sure the queries are performant? Things don't matter when we have 100 records in a database, right? But when we have millions of records, everything matters. So again, it's a massive topic. As you can see, entire careers are spent on one subtopic that I have laid out here. Okay, so, but it may be good to just lean back and think about these and see if any of these ideas and topics resonate with you. Then you can explore them in further detail. Okay, and then the last big thing is, given that databases have so much to do with them, now we have start to ask the question, well, this is true for relational data, but obviously there can be data that is not easily thought of in terms of relations. The best example are documents, which naturally tend to be hierarchical. They tend to be nested structures, right? So, I mean, the simplest example of a document being that there's an article, it has paragraphs, sentences, and words. You can see that there's a natural hierarchy here. And hierarchical structures don't, again, you can think about this abstractly, but hierarchical structures are slightly different to work with than relational structures. And you can map hierarchical structures into relational and vice versa and so on, but people have created databases that deal directly with hierarchical data. Graphs are a good example of hierarchical data. So there are graph databases and so on. Okay, very interesting type of hierarchical data is a web page is a hierarchical structure, an actual web page, right? And a document is also hierarchical. So there are many things that can be done here. In finance and so on, there's some interest about columnar databases. So columnar databases are ones, so you can ask when you build a database, it's kind of interesting. You can ask whether you build a database where you focus on data being stored in rows, as we did in files, a sequence of rows or a sequence of columns. And there are many useful cases where column structures are more efficient. An example is, for example, if you are working in algo trading and you want to manage stock prices and you have 1,000 stocks in your portfolio, every second or every millisecond you get 1,000 price updates. And it's like a whole current price column that gets updated. So it's easier and more efficient to just update a column than to go to loop through the rows and update each row. So then there's a whole technology of columnar databases optimized for that kind of use case, right? And finally, there's this movement. Some of you must have at least been curious or encountered it. It's called NoSQL movement. But the NoSQL movement is not saying don't use SQL. It's kind of saying not only SQL. And by that, it means that we can use all of these alternate strategies for managing data. Okay, again, you can see it's very broad. I just thought I would take 5-10 minutes to show all of you that there's a very broad space of ideas related to managing data, right? All of them interesting, potentially time consuming, and many of them worth investing time to master, okay? And then this is all data with some kind of structure. Finally, there's unstructured data too. And by unstructured data, I mean like a blob or a binary or even an image, right? The substructure inside an image is not very useful. And if you're doing image recognition, pattern recognition, self-driving cars, there's a lot of unstructured data that you have to manage, gigabytes and terabytes of it. And again, we should be searching for strategies to do this well. As you can see, by calling it unstructured data, it means there's very little natural structure that you can use, makes this problem really hard to do extremely well. Okay, so Cord's brilliant insight into using the structure and the data is completely defeated in this unstructured data. what happens, what is a kind of quick win could be, you could create metadata that is structured and then have pointers to unstructured data. That's kind of a throwaway quick win. But otherwise, this problem is also very challenging. Okay, so I've given you a quick overview of all the stuff that goes beyond databases. I don't mean for you to be overwhelmed by it, but just recognizing how many beautiful ideas are out there, how many beautiful things to learn and analyze. And then, of course, now to remind you, let's put this all aside and focus on mastering SQL and files and doing a lot of practice. With that, I do want to wind down. I would love it if people have any questions for me. Anything? If not, questions, comments? Was the session okay? Did you learn what you wanted to? Did I get to the right level of details? Or anyone? Oh, thank you. Thank you, Jeremy. Yes. Yes, please. Yes, please make sure that I cannot stress, right? We are coming towards the end of the course, but even now there's like 2 weeks left of good practice time. If you can, accelerate your practice efforts and spend an hour writing code, that would help you a lot. Hopefully these notebooks and the code board labs give you plenty of opportunities, structured opportunities to write and manipulate code and get experience. And I'm always here. If you have questions, don't hesitate to reach out. So then I won't hold you any longer. I think we are a few minutes early, but that's great. Enjoy the rest of your day and your weekend. And I am on email, so if you need anything, send me a note. And on Monday, we have time in office hours. If any of you want to go through any of these topics in more detail, I'm happy to do that as well. Thank you. Yes, so someone has a question. Yes. What mark? Yes, I think this question was asked before. Okay, so the mark you need is like 65%. But of course, if you want to get 65% and you're having trouble with it, just reach out to me, okay? I don't want any of you to fail because of a mark. The real thing that I want for all of you is that you learn this topic and you're interested in this topic and you're more curious than when you started and more skilled than when you started. So yes, 65% is what is needed. If you have any troubles getting there, let me know and I can either give you the answers or work with you on the answers or whatever, okay? So this course is not about a minimum grade. This course is about learning something. So as long as all of you are achieving this, I'm happy to work with you to get you through any minimum, okay? But it's good to have a minimum and it's good to have something you want to finish, right? So please go ahead and do that. Okay, I'll let all of you go and yeah, if you have problems, we can discuss it. Is there if anyone wants to redo a past due quiz, just come back, just send me an email and I'll work with you. It's more important for me that all of you work regularly, okay? So if you need to redo something, just reach out to me. I'm here to help. Write a lot of code, have fun, enjoy your weekend. Thank you.